So next deletion method is deleting the last node. So here we are going to see how to delete the last node from the doubly linked list. Okay, so here we have to find the last node. Okay, we have to find the last node. So to find the last node, what we are doing means here the last node's next is null. Okay, so this is the last node, this is the last node, and this next part is null. So by using that only we are going to find the last node. Okay, so we have seen many algorithms. So normally how we have checked, so we will use the pointer and we will move the pointer, right? So how we will check? PTR tends to next is not equal to null. So this is the condition we will use. If this condition is false, means what is the meaning? We have find the last node, then we can remove it. Okay, then what we have to do? The last node, so this will be the PTR node when you are doing the process, and this previous node, okay, this previous node means this node, and this node's next means this particular part, we have to make it as a null. Okay, so we will see the code. So we are using one pointer variable, then we are assigning PTR is equal to start. So this is a start node and we are making this as a PTR node. Then already I said we have to check the condition. What condition we are checking? PTR tends to next is not equal to null. So this next part, okay, so this is the next part for this node, this is the next part, and this is the next part, this is the next part. So PTR tends to next is not equal to null. If it is not equal to null means it is true, otherwise it is false. And if this condition is true means we have to execute this statement, that is PTR is equal to PTR tends to next. Okay, PTR tends to next. So we are checking this condition, PTR tends to next is not equal to null. Yes, it is not equal to null. So what we have to do? We have to execute this line. So that is PTR tends to next. PTR is equal to PTR tends to next. So this will become as a PTR. Next we are checking. PTR tends to next is not equal to null. It is not null. Here it is not null. So we are moving to the next node. And here we are checking. So it is also not null. So we are moving to the next node. So this is a PTR. And we are checking next is not null. Yes. So we are moving to here. So PTR. Now we are checking here. It is null. So here the condition becomes false. So now the condition becomes false here. So what we have to do? We have to come out of the loop and we have to execute the statement. That is PTR tends to previous. So this is a PTR node and this previous node. So this is a previous node, right? This is a previous. This previous node's next. So next means this particular part become as a null. Okay, this is a PTR node and this next is this node and this node's previous is this particular part. So this is null. Then by using the free function, we are removing this PTR node from the linked list. Okay, we are removing the list. So here simple, we have to find the last node and we are removing. And before removing that particular node, the last node's previous node, next part, we have to change it as a null. Okay. So this is the algorithm. First we are checking underflow. Then next what we are doing, we are assigning PTR is equal to start. Then we are checking the condition. So here we have to repeat the step 4 until this condition becomes false. So if this condition is true means we have to execute this line, that is PTR is equal to PTR tends to next. Then if the condition becomes false means we have to go to the fifth step, that is PTR tends to previous tends to next is equal to null. So we are assigning that. Then by using the free function, we are removing the PTR and it will return the start. So this is the way to delete the last node from the list. So here we have to check this condition. If this condition becomes false means we have reached the last node and we can remove the node from the list.